Hi, and welcome to day 2. The title is actually Awkward, Who Chose the Number 360 Anyway? And this is Radians, and we're starting on the 3rd page in today. So I just wanted to kind of jump right to the chase so this isn't a super long video. And we're talking about radians today. A circle is defined by a point and a radius. If we start with a circle of any radius and look at a sector, and a sector is a section of the circle, with an arc length equal to the length of the radius, then the central angle of the sector is always the same size. We define a radian to be the measure of that central angle and denote it by 1 radian. So when our radius is equal to the arc length, then our angle measurement will be 1 radian. And it doesn't matter what size circle we have, this will always be the same measure, same proportion. Thus, a radian measures how far 1 radius will wrap around the circle. For any circle, it takes 2 pi, approximately 3.6 radius lengths, to wrap around the circumference. In the figure, 6 radius lengths are shown around the circle, with roughly 0.3 radius lengths left over. And you can see here on this picture, not so much in your packet, they're all in different colors. And we're going to use a protractor that measures the angles. Use a protractor that measures angles in degrees to find approximate degree measurement for an angle with measure 1 radian. Use one of the figures from the previous discussion up above. If I were to take a protractor and measure it, it would be approximately 57 degrees, and I can show you that in class. So examples 1 through 4, we're going to convert from degrees to radians. When we convert from degrees to radians, so if I'm going from degrees to radians, we are going to multiply by pi over 180. So if I have 45 degrees, 45 degrees is 1/8 of a turn on a circle, because 90 degrees would be a quarter, because each quadrant is worth 90 degrees, so 45 degrees is half of a quadrant. So I'd have 8 sections that measure 45 degrees in a circle. So if I have 1/8 of 2 pi, because that's all the way around the circle, radians, then when I multiply it here, I'd end up with pi over 4 radians is what 45 degrees is equal to. So the easy way to do that is 45 times pi over 180, and 45 goes into 180 4 times, so I end up with pi over 4. So convert from degrees to radians. This one is a little bit harder. I don't know how many turns 33 degrees is, so I'm just going to say 33 degrees is equal to 33 out of 360 degrees to figure out how many turns it is, times 2 pi. And let's see here, 2 goes into 361, or 180 times. And let's see here, 3 goes in here 11 times, and 3 goes in here 60 times. So this would be equal to 11 pi over 60. Or I can just do the shortcut, which is 33 times pi over 180. And 3 goes in here 11 times, 3 goes in here 60 times, so you can still see that that's 11 pi over 60. Convert from radians to degrees. From radians to degrees, we multiply by 180 over pi. So if I have negative pi over, well, that was funny, 3, I'm going to multiply it by 180 over pi. My pi's are going to cancel out. 3 goes into 180 is 60 times, so it's equal to negative 60 degrees. Convert from radians to degrees. So if I have 19 pi over 17, I'm going to multiply by pi, 180, over pi. Pi's will cancel. And, yucca. I don't see anything good there. I don't think anything is going to reduce. So I'm just going to have to do 19 times 180. When I do that, I get 3,420 over 17, which is approximately 201 degrees. I'm going to go back up here. Another thing I can do is just sub in 180 for pi. Because pi is equal to 180, so if I take negative 180 over 3, I'll get negative 60. All right, let's see. Let's look on the next page. Complete the table below, converting from degrees to radians or from radians to degrees as necessary. Leave your answers in exact form involving pi. Exact form means no decimals. So it's not a calculator problem necessarily. Involving pi means reduce fractions. So we already said that 45 degrees is pi over 4 radians. If I have 120 degrees, I'm going to take 120 and multiply it, because I want to turn it into radians, by pi over 180. 60 goes in here twice, 60 goes in here 3 times, so I have 2 pi over 3 radians. Negative 5 pi over 6, sorry, 6, not 60. I'm going to substitute in 180 for pi. 6 goes in here 30 times, so it's negative 150 degrees. 3 pi over 2 would be 3 times 180 divided by 2. 2 goes in here 90 times, so 3 times 9 is 27, so that's 270 degrees. 450 would be 450 times pi over 180, and let's see here, 90 goes in here twice, 90 goes in here 5 times, so it's pi over 2. X degrees, well, when we're converting from degrees to radians, we do the degrees times 180 divided by pi. Or sorry, I'm upside down. Yikes. So we're turning it into radians. It'd be pi over 180. So it's x times pi over 180 is my generic form. And to turn it into degrees from radians, if I have x degrees and I want to turn it into radians, I'm going to do 180 over pi. So I will get 180 over pi times x degrees. And we're not going to mess with number 7. So that's basically it. So when you're converting between radians and degrees, you're either multiplying by pi over 180 to turn it into a degree, which is here, or you're going to substitute 180 in for pi and figure out how many degrees it's equal to. We will work more with this in class tomorrow. And I think that's it.